We are going to look at the possibility of including categorical or qualitative independent predictors or variables to be used in explaining the variations in the response variable, which is our list price. Let's head over to StatCrunch and look at the dataset. This time I'm going to look at this version of the same dataset. You will notice that I have just about the same piece here over here, but this time I have included a new variable called area. I have set it to 1 if the house is located on the foothills, and it is equal to, if you scroll all the way down, area is equal to 0 if the home is not on foothills. Take note that area in this case is a categorical variable that has two categories. In statistics, we say area has two levels, either on the foothills, which I've set to 1, and not on the foothills, which I've set to 0. So you see, whenever you want to include a categorical independent variable or explanatory variable, the first step you must take is the data preparation steps. For instance, in the case of area, when it has two levels, I'm going to introduce one dummy variable. And the dummy variable is area itself because the dummy variable will have 1 for one level and 0 for another level. However, if we're dealing with a decision maker who wants to build what? A regression model and wants to include the university class standing, and it has 5 possible levels of response. Let's say freshman, or let's just say high school, graduate, freshman, sophomore, junior, and senior. So this particular categorical variable, university class standing, has what? 5 levels. I am going to need to introduce 5 minus 1 dummy variables. So I can say university dummy variable 1, university dummy variable 2, university dummy variable 3, university dummy variable 4. And in that case, I would need to assign university what? Class dummy variable 1 to, let's say, senior. In other words, if any student is senior, this variable will have the value 1 and it will be 0 elsewhere. Then university dummy variable 2 will be for junior. So for any student whose university class standing is junior, you will have 1 and otherwise it will be 0. These are the variables that will be included in the model. In the example we have here, we're looking at area where it is equal to 1 and 0 otherwise. We only need one dummy variable, which we already have because 1 is already set for foothills and 0 for otherwise. So how do I include that in my model? I'll go to statistics, go to regression, multiple regression, and I have what? Price. That is this guy right here. And I would like to fit it as a function of what? Square foot, age, bedrooms, bathrooms, garage number, and area. And I can compute that. So I have my fitted regression model here, which also includes the regression slope for area. All right, let's go back to our notes. I have that output here, and I can see that whether the home is on the foothills is very, very what? Significant. However, there are some issues related to the expected signs on bedrooms and bathrooms. I would expect that the price of a home should what? Increase as the number of bedrooms and the number of bathrooms increases. However, these are negative values. That tells me that I might be dealing with issues related to what? Multicollinearity. So whenever I see this, this might inform the need to drop maybe one or both of this. And I can do that. And that gives us a reason to start thinking about improving the model. And what are some of the ways to improve the model? I'm going to try to what? To drop the two misbehaving independent variables. So I can go back to StatCrunch. I'm going to go to Edit. And this time, I don't want bedrooms and bathrooms. So price still. What I want this time, I want just the square foot and then age, garage number, and then area. And let's compute that. And let's see what we have. So I have this output where back on our notes, you will notice here that we have what? Square foot, which is what? Positive, because as the list price increases, we want it to also, as the square foot increases, we want the list price to also increase. As the age increases, however, we expect what? The list price tends often to what? To decrease. That makes sense. Garage number, positive. This is also what? Positive. And our p-value in this case here for the overall regression model is the indicator that the overall regression model is significant. Then, if you remember, we talked about the R-square adjusted being a very useful metric for comparing what? Two models. I have 0.89. That is not significantly what? Uh, Lower. That is not extremely lower than what I had before here. This was 0.90, 90%, 89%. So even when I dropped these two guys, bedroom and bathroom, there wasn't much change to the performance of the model because it went from 90% to what? To about 89.6, I mean 89.68%, approximately 90%. So dropping bathrooms and bedrooms seems to be okay. And then that brings us to the question of the regression, the estimate of the regression slope for area. We have 6578. What does this number mean? Well, it means that on average, a house on the foothills where area is equal to 1 is estimated to cost higher. How do I know higher? That is because the estimate is a positive number and by approximately what? $60,578.05, which is the value we have here, while holding all other what? Predictors included in the model constant. So this is one of the ways that we can improve on the model and not sacrifice a ton of what? Performance metrics. At this point, we come to the conclusion of our lesson on multiple linear regression models.